This is section 4 of the Paper 2 Higher Maths Mock. The price of an iPhone is reduced by 20%. So here the reduction has already happened. So if we imagine, as we always do, that we start at 100%, 20% has already been taken off in the sale, so we are now left at 80%. So the sale price represents 80% of what it started as. So here, that means that £260 represents 80%. We want to find 100%, the starting value. Easiest way of doing that is in 2 steps. If we divide by 80, that gives us what 1% is. So 260 divided by 80 gives us 3.25, and then times by 100 to give us 100%, so in this example £325. Now the question does ask, by how much is the price reduced? So here it started at 325, in the sale it has gone down to 260, so doing that as a subtraction gives us £65. That's how much the price has gone down by. Second example, using the same idea, but here a slightly trickier percentage. Again, we say that we start on 100%, taking away 12.5% in the sale here means that we are left with 87.5% of what we started. So that 87.5% represents £350 or vice versa. Again, we would divide by 87.5, that would find 1% for us. 350 divided by 87.5 is 4. So 100%, which we times by 100 to find, gives us £400. So the original price was 400. In the sale, it was 350. So the price must have gone down by £50. Next topic we've got is Venn diagrams. This also appeared on paper 1, but this is going to be in a slightly different format. So here at the top, this symbol represents the total, the set, everything that needs to appear within the Venn diagram. Here S and E represent square and even numbers. So all it wants me to do on this question is put these numbers at the top into my Venn diagram. The number 1 is square but not even, so it will go in the square section. 2 is even but not square. 3 isn't even, it isn't square, so 3 would go on the outside, inside the rectangle, outside the circles. 4 is square and even, so it goes in the centre, the overlap. 5 is neither, so it goes on the outside. 6 is even but not square. 7 is neither. 8, not a square number, but it is even. 9 is a square number, but is odd, so it doesn't need to go in the even section. 10 is even, but not square. 11 is neither, so it goes on the outside. And 12 is even, but not square. And that's a completed Venn diagram. The next topic draws together, the next question draws together a lot of different areas within maths, including area, coordinates and properties of trapezia. Here we've got a trapezium. Now there is very little information given on the diagram other than the fact that the height of this trapezium is 12. So here we've got that the trapezium has an area of 60 square units. We'll just call the area 60. So the first thing I would do is write down the area of a trapezium. So that is half times A and B, which are the lengths of the 2 parallel sides, times height. So in our example, we've got that half times A plus B times height, which here it says is 12, well that equals 60. Let's see it. So what we get is if I do 60 divided by 12 divided by a half, again we can do this on the calculator, that would give me that A plus b would need to equal 10. Now, because it doesn't tell us exactly what values a and b need to take, I'm actually just going to pick any value I want. So I'm going to say that a, the top of this trapezium, is going to be 2, and b, the bottom of this trapezium, is going to be 8. I could have picked any values on the one condition that this one is smaller than this one. Again, just go with any value because it does say possible coordinates. I'm going to say that this coordinate here is the coordinate 7, 0. 7 is just an arbitrarily picked number. I know it's 0 because it is on the x-axis. Now if this number here is 7, 0, we know that because the bottom of the trapezium is 8 long, that if I add 8 onto the 7, this tells me that this coordinate over here must be 15, 0, because I needed a length of 8 between them. For the numbers up at the top, straight away, because I know they are at 12 on the y-axis, I must have 12 as the second number in each case. In terms of the other numbers, they must have a difference of 2, and they must be somewhere between 7 and 15. So to make this as easy as possible, I'm going to say that this one is 8, just a little bit further along the x-axis than the first one. And if we need this one 2 further along, because we said that a is 2, I'm going to say that that is 10. There are multiple different answers that you could give for this question. This is just one of them. The next question is looking at prime numbers, and in particular prime factors. Here it is saying that a letter y, or a number represented by the letter y, is equal to a to the power 4 times b to the power 3 times c, where a, b and c are all prime. All it wants us to do is give an example when y is even. So for a number to be even, it means it must be made up of at least one even factor. So all I need to do to ensure that this number is even is write down 3 different prime numbers where one of them has to be even. Now here the little trick is there is only one even prime number. So I'm going to say that c is the number 2. So for a and b I just need 2 other prime numbers. Remember, a prime number is anything that can be divided by just 2 distinct factors, or in other words, just one in itself. So the other 2 numbers I'm going to use are 3 and 5. So the first 3 prime numbers. Don't fall into the pitfall a lot of people do. 1 is not prime. So if I actually work this out to prove it is even, I would have 3 to the power 4 times 5 to the power 3 times 2, which if I work this out, 3 to the power 4 is 81, 5 cubed is 125, multiplied by 2. At this point we would have to use a calculator and do 81 multiplied by 125 multiplied by 2, and this comes out as 20,250, which is obviously prime because it ends in a 0.